Describe the slope of each line, then find the slope. Part A. The line rises from left to right, so the slope is positive. To find the slope of the line, use the slope formula m equals the quantity y2 minus y1 divided by the quantity x2 minus x1. Let x1, y1 be the point -2, -3, and let x2, y2 be the point 1, 3. y2 minus y1 is 3 minus -3, and x2 minus x1 is 1 minus -2. So m equals the quantity 3 minus -3 divided by the quantity 1 minus -2, which simplifies to m equals 6 divided by 3. So the slope of the line is 2. Part B. The line falls from left to right, so the slope is negative. To find the slope of the line, use the slope formula m equals the quantity y2 minus y1 divided by the quantity x2 minus x1. Let x1, y1 be the point -2, 0, and let x2, y2 be the point 2, -2. y2 minus y1 is -2 minus 0, and x2 minus x1 is 2 minus -2. So m equals the quantity -2 minus 0 divided by the quantity 2 minus -2, which simplifies to m equals -2 divided by 4. So the slope of the line is -1/2. The points represented by each table lie on a line. How can you find the slope of each line from the table? What is the slope of each line? Part A. To find the slope of a line from a table, choose any 2 points from the table and use the slope formula m equals the quantity y2 minus y1 divided by the quantity x2 minus x1. Let x1, y1 be the point 0, 5. Let x2, y2 be the point 3, 11. So y2 minus y1 is 11 minus 5, and x2 minus x1 is 3 minus 0. 11 minus 5 equals 6, and 3 minus 0 equals 3. 6 divided by 3 equals 2, so the slope of the line is 2. Part B. To find the slope of the line, choose any 2 points from the table and use the slope formula m equals the quantity y2 minus y1 divided by the quantity x2 minus x1. Let x1, y1 be the point 0, -2. And let x2, y2 be the point -4, -2. So y2 minus y1 is -2 minus -2, and x2 minus x1 is -4 minus 0. -2 minus -2 is 0, and -4 minus 0 is -4. 0 divided by -4 is 0, so the slope of the line is 0. Part C. To find the slope of the line from the table, choose any 2 points from the table and use the slope formula m equals the quantity y2 minus y1 divided by the quantity x2 minus x1. Let x1, y1 be the point 4, -2. Let x2, y2 be the point 4, 4. So y2 minus y1 is 4 minus -2, and x2 minus x1 is 4 minus 4. 4 minus -2 is 6, and 4 minus 4 is 0. Because division by 0 is undefined, the slope of the line is undefined. Find the slope and the y-intercept of the graph of each linear equation. Part A. Y equals 2x minus 3. Rewrite the equation in the form y equals mx plus b, where m is the slope and b is the y-intercept. The equation can be written as y equals 2x plus negative 3. So the slope is 2 and the y-intercept is negative 3. Part B. Y equals negative 4 and 5/10. Rewrite the equation in the form y equals mx plus b, where m is the slope and b is the y-intercept. The equation can be written as y equals 0x plus negative 4 and 5/10. So the slope is 0 and the y-intercept is negative 4 and 5/10. Part C. 6x minus y equals 8. Rewrite the equation in the form y equals mx plus b, where m is the slope and b is the y-intercept. To write the equation in the form y equals mx plus b, subtract 6x from each side of the equation. This gives negative y equals 8 minus 6x. Next, divide each side of the equation by negative 1. Y equals negative 8 plus 6x. So the equation can be written as y equals 6x plus negative 8. So the slope is 6 and the y-intercept is negative 8. Graph y plus x equals negative 2. Identify the x-intercept. First you want to rewrite the equation in slope-intercept form. To do this, subtract x from each side of the equation, which gives you y equals negative x minus 2. The equation is now in slope-intercept form, so m equals negative 1 and b equals negative 2. The y-intercept is negative 2, so plot 0, negative 2. Now you want to use the slope to find another point on the line. Slope equals rise over run. So because m equals negative 1, and negative 1 can be rewritten as negative 1 divided by 1, you want to plot a point that is 1 unit down and 1 unit right from 0, negative 2. Draw a line through the 2 points. The line crosses the x-axis at negative 2, 0, so the x-intercept is negative 2. Graph y plus A linear function g models a relationship in which the dependent variable increases 2 units for every 3 units the independent variable increases. Graph g when g of 0 equals 2. Identify the slope, y-intercept, and x-intercept of the graph. Because the function g is linear, it has a constant rate of change. Let x represent the independent variable and y represent the dependent variable. To graph the function, you first want to find the slope. When the dependent variable increases by 2 units, the change in y is positive 2. When the independent variable increases by 3 units, the change in x is positive 3. So the slope is 2 divided by 3, or 2/3. Next you want to find the y-intercept. The statement g of 0 equals 2 indicates that when x equals 0, y equals 2. So the y-intercept is 2. Because the y-intercept is 2, plot the point 0, 2. Next you want to use the slope to find another point on the line. Because a slope of 2/3 can be rewritten as negative 2 divided by negative 3, You want to plot a point that is 2 units down and 3 units left of the point 0, 2. Draw a line through the points. The line crosses the x-axis at -3, 0, so the x-intercept is -3. The elevation h in feet of a submersible is modeled by the function h of t equals 550t minus 11,000, where t is the time in minutes since the submersible began to ascend. Part A. Graph the function and identify its domain and range. The time t must be greater than or equal to 0. The elevation h is below sea level and must be less than or equal to 0, so graph the function in quadrant 4. The function h of t equals 550t minus 11,000 is already in slope-intercept form, so the slope is 550 and the h-intercept is -11,000. Because the h-intercept is -11,000, plot the point 0, -11,000. The slope is 550, which can be rewritten as 11,020ths. So plot a point that is 11,000 units up and 20 units right of the point 0, -11,000. Then draw a line segment through the points. The domain is the set of all possible values of t, so the domain is the set of all real numbers greater than or equal to 0 and less than or equal to 20, which can be represented by the inequality 0 less than or equal to t less than or equal to 20. The range is the set of all possible values of h, so the range of the function is the set of all real numbers greater than or equal to -11,000 and less than or equal to 0, which can be represented by the inequality -11,000 less than or equal to h less than or equal to 0. Part B. Interpret the slope and the intercepts of the graph. T is the independent variable and h is the dependent variable, so the slope is the change in elevation over the change in time. Here the slope is 550, so the submersible ascends at a rate of 550 feet per minute. The h-intercept is the elevation after 0 minutes. Here the h-intercept is -11,000. So the elevation of the submersible when it begins its ascent is -11,000 feet. The t-intercept is the number of minutes it takes the submersible to reach an elevation of 0 feet. Here the t-intercept is 20, so the submersible takes 20 minutes to reach sea level.